Well, howdy, y'all. Today we're going to be doing application problems. So why don't we go ahead and get started? The diagonal of a parallelogram is 88 centimeters and 66 centimeters, and the shorter side is 20 centimeters. Find the acute angle formed by the two diagonals to the nearest tenth. Okay, so we have a picture down here, and why don't we go ahead and label what we know. We know the short side of this parallelogram is 20 centimeters. So we'll put a 20 there. And then I'm going to call this entire diagonal, he's going to be 66 centimeters. And then this bigger diagonal, we're going to make him 88 centimeters. Okay, well, I'm going to go ahead and redraw a picture just so we have some nice picture to deal with. And over here we have, this will be our 20 centimeters all nice and blown up. And then we have this triangle. This triangle is made from the short side and these guys. So this is the picture I just drew. Now, this side is only half of that 66, so he's 33. And that's half of 88, so it's going to be 44. And we want to know what this side length is. But because we have a side, 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 that's what we have, side, 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 I'm going to use the law of cosines. And the law of cosines, which if we called this A, B, and C, law of cosines that deals with the angle of B would be b squared, little b squared, for side b squared, is equal to a squared plus c squared. And this looks a lot like the Pythagorean theorem, minus 2 times AC, which are the two side lengths here, all times the cosine, because it's the law of cosines, times the cosine of big B, or the angle B, which is what we're trying to find. Excuse me. So why don't we go ahead and plug in numbers. I have B is 20, so 20 squared is equal to 33 squared plus 44 squared minus 2 times 33 times 44 all times the cosine of B. So I'm going to go ahead and solve this for the cosine of B, and I'll be right back. Okay, well, welcome back. So when I solved for the cosine of B, I subtracted over the 33 squared and the 44 squared. As soon as I find my cursor, oh, there we go. So I subtracted over the 33 squared, the 44 squared, and then divided by negative 2 times 33 times 44. So that's all over here. When I typed all of that into my calculator, I got 0.90392566198. I just wrote this. But what I'm going to do is in my calculator, I'm going to take the arc cosine of my answer. So I'm going to take the arc cosine to the negative 1 of 0.9039. Of course, in my calculator, I have more digits. But I get the fact that B, so the measure of angle B, then becomes, as I do it, I get measure of angle B is 25.3. So 25.3 degrees. And we did it to the nearest tenth because that's what it asked. Okay. So then on your sheet, I'm going to go ahead and skip down to number 6. And with number 6, we have a vertical tower stands at the top of a hill, which is inclined at 16 degrees. So I know that this hill over here is 16 degrees. It also means that this guy right here, because it's a parallel, is also 16 degrees. At a point 95 feet, so from this guy right here to this guy right here is 95 feet. 90 feet downhill, an observer finds that the angle of elevation to the top of the tower is 54 degrees. How tall is the tower? Okay, so we know that from the hill to the angle of elevation is 54 degrees. Now, guys, this is a really tiny picture, so I'm going to go ahead and redraw the picture. Oh, real fast before I do it, realize that the parallel, which if that was a straight line, here forms a 90 degree with the tower. So that's, we'll call that this line right here. That's our parallel. Then we have the hill. The hill slants up at 16 degrees. And then from here, we have the observer who's staring at the top of this tower. And that would be another 54 degrees. And he's 95 feet away. I want to know how tall the tower is, why. Well, I realize that this is a 90-degree angle, so I have 90, and then 54 plus 16, which is 70 degrees, so it's in red. This degree right here is 70 degrees, so that makes this 20 degrees. That's 20 plus 70 plus the 90 gives me, so now I'm going to redraw my picture because I don't need that bottom half of the triangle anymore. And I have, grab some more space. And I have, where'd my cursor go? So now I have this triangle, with this being 54, this being 20, and I don't know what this is, because I don't know what this degree measure is, but if I solve it, I find that that degree is 180. Is 106. That degree is 106. And then I know that this is 95. I'm solving for this. So why don't we go ahead and label our triangles A, B, C. A, B, C. I'm solving for side A. Now, being I was given a side and an angle, I'm going to use the law of sines. So we remember the law of sines is going to be the side of C. As soon as I find my cursor, here we go. It will be C, or Y, the side C, which is also equal to Y, over the sine of 54 is equal to 95, which is little b, over the sine of big B, which was 20. Now, I want you guys to go ahead and solve for y, and I'll be right back. Okay, I'm back. And once I solved for y, I got 95 times the sine of 54 over the sine of 20. And when I typed that into my calculator, I got 224.7. Okay, so that would be the height of the tower. It's 224.7 feet. Because we were given our distance in feet. Okay, guys, I will see you in class tomorrow. Have a great night.